Hey everyone, and welcome to today's Explainer. I'm absolutely thrilled to be your guide for this masterclass. Today, we're tackling a fundamental, foundational concept in chemistry: physical versus chemical changes. Whether you're prepping for a major science exam, trying to wrap your head around molecules, or you just want to understand the physical world around you a little bit better, this lesson is literally designed just for you. We're going to break things down logically, step by step, and we're focusing on pure conceptual understanding rather than just rote memorization. So get ready to completely master this topic.
Okay, let's dive right into this. Imagine you're holding a glass bottle. You drop it, and it shatters on the floor into 100 tiny, sharp pieces. Now imagine you take a solid block of wood, toss it into a campfire, and burn it until all that's left is a pile of gray ash. In both scenarios, the original object looks completely destroyed, right? But chemically speaking, these two events are worlds apart. One is just a mere change in appearance, while the other is a total structural transformation. By the end of this explainer, you're going to know exactly how to tell the difference.
So, here is our game plan for today. 1. Defining physical changes. 2. The state change misconception. 3. Defining chemical changes. And 4. An exam revision summary.
All right, kicking things off with Section 1, Defining Physical Changes. Whenever you're observing a change and trying to figure out exactly how to categorize it, there's one golden question I want you to always ask yourself. Seriously, write this down if you're taking notes. Did a new substance form? If the answer is no, then you are looking at a physical change. A physical change is a change where an object alters its shape and size, but importantly, it does not form any new substance. The material might look entirely different to your eyes, sure, but its core chemical identity remains exactly the same.
And this brilliantly illustrates exactly what we mean. Let's apply our golden question to these real-life examples. Think back to our glass bottle. When it falls and breaks into several small pieces, the shape and size have drastically changed. However, every single tiny shard on the floor is still completely made of glass. You didn't create a new chemical material, you just changed its physical dimensions. The exact same logic applies to cutting vegetables. You change their shape, but those veggies strictly retain their original properties. Finally, consider dissolving sugar into water. When you stir it in, you get a mixture. The sugar crystals seem to disappear, changing their shape and size, but they absolutely retain their properties in the water. I mean, that's why the water still tastes sweet. The sugar is still sugar. In all three of these cases, no new substance was formed.
Moving right along to Section 2, the state change misconception.
Let's see how this builds on what we just learned. The source material actually highlights a comparison between an ice molecule, listing it as having one carbon atom and two hydrogen atoms, versus a water molecule having one oxygen atom and two hydrogen atoms. Now, while that specific atomic breakdown might sound highly unusual, the vital conceptual takeaway the source is driving at remains the exact same. The process of melting does not yield a fundamentally new substance. It's all about continuity. When a substance like ice converts into liquid water, you aren't fundamentally generating a brand new chemical entity. The foundational rule absolutely remains.
Because of this strict rule, we can confidently categorize all common state changes of matter. Melting, which is converting ice to water; boiling, where liquid water is converted into steam or a gas; and freezing, where liquid water converts right back into solid ice. Listen, in every single one of these processes, no new substance is formed. The molecules are just changing how closely they're packed together and how much energy they have. So if your exam asks you to categorize melting, boiling, or freezing, lock it in your mind right now. These are strictly physical changes.
Okay, let's flip the script. Section 3, Defining Chemical Changes.
Now, what's really interesting about this is the stark contrast it presents to everything we've discussed so far. A chemical change is defined as a process that results in the formation of completely new substances. We aren't just altering the shape, the size, or the state of matter anymore. Instead, we are taking raw materials and totally transforming them into entirely new materials that have entirely different chemical properties.
Let's walk through how this works step by step using an advanced real-world example: burning wood. In step 1, we start with wood. Chemistry tells us that wood is an organic material made mostly out of carbon and hydrogen, which is why it's known as a hydrocarbon. We expose this hydrocarbon to oxygen. In step 2, we introduce combustion, which is simply the scientific term for burning that organic material. Then we get to step 3, the result. The original wood is gone. In its place, the burning of the hydrocarbon in the presence of oxygen has resulted in the formation of brand new substances. specifically carbon dioxide and water. Because we started with a hydrocarbon and ended up with carbon dioxide and water, we have absolutely created new substances. Therefore, this is definitively a chemical change.
But it is absolutely crucial to remember that chemical changes aren't just things that happen in a laboratory or at a campfire. They are happening inside your own body right at this very moment. Take digestion, for example. During digestion, enzymes in your body convert complex molecules, like carbohydrates, into completely new and simpler substances, like glucose. That is a chemical change. Or look at respiration. During respiration, your body takes that glucose, adds oxygen, and chemically converts it into carbon dioxide and water to give you energy. You, my friend, are literally a walking, talking factory of continuous chemical changes.
All right, let's bring it all home with Section 4, our exam revision summary.
Let's review these features side by side to really lock in your test strategy. The absolute most important factor is our golden question. New substance? For a physical change, the answer is always, categorically, no. For a chemical change, the answer is always yes. So the crucial point is that this single question is your ultimate test strategy. If you see examples like melting ice, cutting vegetables, or dissolving sugar, you immediately know it's a physical change because nothing new was made. If you see burning wood, digesting food, or cellular respiration, you know for sure you're dealing with a chemical change because entirely new materials were formed.
Which brings us to the end of our masterclass, but really the true beginning of your real-world application. I want to leave you with a quick challenge. Look around you right now. Can you identify one physical change and one chemical change happening in your environment at this exact moment? Maybe there's ice melting in your drink, a purely physical change. Or maybe a plant sitting by your window is quietly photosynthesizing, which is a really complex chemical change. Keep that golden question in your mind, and I promise you, you'll never look at the everyday world quite the same way again. Thank you so much for joining me for this explainer. Stay curious and happy studying.